January 1945, France. Private Audie Murphy climbs atop a burning M10 tank destroyer that's about to explode. German infantry, 250 soldiers, are advancing across an open field toward his position. Murphy has minutes before they overrun him. He grabs the M2 Browning .50 caliber machine gun mounted on the burning vehicle and opens fire. For 1 hour alone, Murphy holds off an entire German company. The M2 never jams, never overheats, never fails. When Murphy finally runs out of ammunition, he's killed or wounded over 50 German soldiers. He receives the Medal of Honor. That M2 Browning was manufactured in 1933, 12 years old, when Murphy used it to win America's highest award for valor. Fast forward to 2018. U.S. Army weapons testers examine an M2 scheduled for upgrade. The serial number shows it was built in 1933, the same year as Murphy's gun. They test it anyway. Full diagnostics, accuracy testing, stress firing. The verdict: perfectly serviceable. This 85-year-old gun has fired over 1.2 million rounds and still shoots with sub-MOA accuracy. The M2 Browning, designed in 1918, adopted in 1933, is America's longest-serving military weapon. It fought in World War II, Korea, Vietnam, Iraq, Afghanistan, and Ukraine. Every attempt to replace it has failed. The Pentagon tried in the 1980s, 1990s, and 2000s. All replacement programs were canceled. Deuce just keeps winning. Before we reveal why this 107-year-old design beats every modern weapon, smash that subscribe button and drop a like. Comment which war you think the M2 will still be fighting in. This channel reveals engineering secrets the military doesn't talk about. Now let me show you why Deuce is immortal. 1918 World War I is ending, but John Moses Browning, already famous for designing the M1911 pistol and the M1917 machine gun, is working on something that will outlive him by a century. The U.S. Army approaches Browning with a problem: German tanks. The Renault FT-17 and British Mark IV tanks dominate European battlefields, but American infantry has no weapon capable of penetrating armor at range. The .30-06 Springfield rounds simply bounce off steel plate. The Army needs a heavy machine gun firing a cartridge powerful enough to punch through tank armor at 500 yards. Browning's solution is characteristically elegant. Scale up his proven M1917 water-cooled machine gun design and create an entirely new cartridge, the .50 caliber Browning machine gun round, later designated .50 BMG. The cartridge is massive, 12.7 mm diameter, 99 mm case length, propelling a 700-grain bullet at 2,800 feet per second. It delivers over 13,000 foot-pounds of muzzle energy, roughly 10 times the power of a .30-06 rifle round. But Browning does something nobody expected. Instead of simply making a bigger water-cooled gun like the M1917, he designs an air-cooled weapon. Water cooling works, the M1917 proved that, but it adds weight, complexity, and vulnerability. The water jacket can be punctured. The cooling system can freeze in winter or boil over during sustained fire. Browning eliminates all of that. His new gun uses a massive, thick barrel that absorbs heat through sheer thermal mass, then dissipates it through air cooling. No water, no hoses, no pumps. Just steel and air. The operating system is pure Browning genius, short recoil operation. When fired, the barrel and bolt recoil together for about 3/4 of an inch, locked together. Then the barrel stops, the bolt continues rearward, extracting the spent case and cocking the firing mechanism. A spring drives the bolt forward, chambering a fresh round, and the barrel returns to battery. The entire cycle happens faster than human perception. The M2 fires between 450 and 600 rounds per minute. Browning completes the prototype in late 1918, just as the armistice is signed. The timing seems unfortunate. The war is over, military procurement is plummeting, and Congress wants to dismantle the wartime military-industrial complex as quickly as possible. The War Department tests the gun in 1919 and 1920, impressed by its performance, but budget constraints delay adoption. Browning dies in 1926, never seeing his final masterpiece enter full military service. The M2 designation becomes official in 1933 when the weapon finally enters mass production. By then, the design is already 15 years old. Critics question whether a gun conceived during World War I is appropriate for modern mechanized warfare. The answer, delivered across the next 9 decades, is an emphatic yes. The M2's fundamental design is so sound, so perfectly engineered for its role, that it requires virtually no modification for nearly a century of service. December 1941. Pearl Harbor burns. America enters World War II with approximately 15,000 M2 Brownings in inventory, a number that seems adequate until the reality of global war sets in. The M2 becomes ubiquitous across every branch of service and every theater of war. Infantry mounts them on tripods for ground defense. Tankers mount them on turrets for anti-aircraft and anti-personnel work. Naval vessels bristle with them for air defense. Aircraft B-17s, B-24s, B-29s carry multiple M2S and dorsal, ventral, and tail turrets. Production explodes. By 1945, American factories have manufactured over 2 million M2 machine guns. This isn't just industrial capacity, it's testament to the design's manufacturability. The M2 uses relatively simple machining operations, standardized parts, and tolerances loose enough that wartime production workers with minimal training can assemble functional weapons. Compare this to German MG-42 production, which required skilled machinists and precision tooling that became increasingly scarce as Allied bombing devastated German industry. The Pacific Theater reveals the M2's versatility immediately. Marines landing at Guadalcanal in August 1942 discover that Japanese bunkers built from palm logs and coral resist .30 caliber machine gun fire. The M2's .50 BMG rounds punch straight through, killing defenders and destroying fortifications. At night, Japanese infantry tactics rely on infiltration and close assault. The M2's distinctive sound, a slower, heavier cadence than the .30 caliber Brownings, becomes reassuring to American troops. When Deuce opens fire, whatever's in front of her dies. Aviation applications prove equally decisive. B-17 Flying Fortresses carry 13 M2S, twin guns in dorsal, ventral, and tail turrets, plus single weapons in nose and waist positions. German fighter pilots learn to respect the combined firepower of a B-17 formation. Each bomber puts out devastating defensive fire, and .50 BMG rounds can down a Bf-109 or FW-190 with just a few hits. The same round that penetrates tank armor at ground level destroys aircraft components, engines, fuel tanks, control surfaces, with catastrophic effect. The gun's reliability under extreme conditions becomes legendary. In the North African desert, temperatures exceeding 120 degrees Fahrenheit, M2S continue firing when other weapons fail. In the Italian mountains during winter 1943-44, temperatures drop below zero, yet M2S function without the lubricant freezing issues that plague other weapons. The air-cooled barrel design proves superior to water-cooled systems in both extremes. No water to freeze, no cooling system to fail in heat. Sustained fire capability separates the M2 from lighter machine guns. The massive barrel absorbs tremendous heat during extended firing. Gunners learn they can fire 200-round belts continuously without the barrel glowing red-hot. Beyond that, barrel changes become necessary, but the quick-change barrel system means a trained crew can swap barrels in under 2 minutes. This endurance makes the M2 ideal for defensive positions where sustained fire is essential. The Normandy invasion showcases M2S in every conceivable role. Naval vessels provide covering fire with deck-mounted guns. Landing craft mount them for suppression during beach assaults. Once ashore, infantry and armor use them to engage German strong points. At Omaha Beach, M2S mounted on half-tracks provide crucial covering fire that allows pinned infantry to advance off the beach. January 26, 1945. Holtzwihr, France. This is where Audie Murphy becomes legend with an M2 Browning. His company, Company B, 15th Infantry Regiment, is defending against a German counterattack involving 6 tanks and 250 infantry. Murphy orders his men to retreat to defensive positions while he coordinates artillery fire. Then he sees the M10 tank destroyer 50 yards away, abandoned but still functional, with its M2 mounted on the turret ring. The M10 is burning. Fuel leaking from punctured tanks could cause an explosion at any moment. Murphy climbs aboard anyway. He gets behind the M2, calls in artillery coordinates on the field telephone, and begins firing into the advancing German infantry. For the next hour, Murphy fights alone atop a burning vehicle that could explode beneath him. The M2 never stops. German infantry get as close as 10 yards. Murphy cuts them down. He fires over 800 rounds, methodically destroying the German attack. When he finally runs out of ammunition and retreats, the German assault has collapsed. Murphy is wounded, shrapnel in his leg, but alive. The M2 saved his life and the lives of his company. The gun itself, perfectly functional when recovered later. Murphy receives the Medal of Honor. The M2 receives nothing, but veterans remember. Korea proves the M2's versatility in an entirely different war. Chinese and North Korean human wave attacks. Mass infantry assaults designed to overwhelm defensive positions through sheer numbers. Meet devastating M2 fire. At the Battle of Chosin Reservoir in November-December 1950, surrounded Marines use M2S to break repeated Chinese attacks in temperatures dropping to -30 degrees Fahrenheit. The guns function flawlessly in cold that freezes water-cooled weapons solid. Staff Sergeant Reckless, the famous pack horse who carried ammunition during the Korean War, most frequently carried belts for M2 machine guns. The voracious appetite of these guns, consuming hundreds of rounds during firefights, meant constant resupply was essential. Yet the reliability meant ammunition was never wasted. When an M2 fired, targets died. Vietnam introduces jungle warfare where the M2's power proves decisive against fortified positions. Viet Cong bunkers built from hardwood logs resist rifle fire and even grenades. The .50 BMG round punches straight through, killing defenders or collapsing structures. River patrol boats bristle with M2S, providing fire support during riverine operations. The gun's ability to engage targets at extended range, effectively out to 2,000 yards, gives American forces standoff capability in ambush situations. Helicopter door gunners initially use M60 machine guns, but some units experiment with M2S despite the weight penalty. The results are devastating. The M2's range and power mean helicopters can engage ground targets from altitudes and distances where return fire is ineffective. A Huey gunship with M2S can suppress an entire tree line from 1,500 yards, something impossible with lighter weapons. The M2's combat record by 1975 spans every climate, every terrain type, and every conceivable tactical situation. It has fired in deserts reaching 140 degrees Fahrenheit and Arctic conditions at -40 degrees Fahrenheit. It has engaged infantry, aircraft, light vehicles, bunkers, and boats. The failure rate remains remarkably low. Properly maintained M2S simply don't break. The 1980s. Pentagon procurement officers decide the M2 is finally obsolete. After all, the gun is approaching 50 years of service. Modern materials, computer-aided design, and advanced manufacturing should produce something better. The service's Advanced Weapons Technology, SAWT program launches with ambitious goals. Develop a .50 caliber machine gun that's lighter, more accurate, and easier to maintain than the M2. Defense contractors salivate at the potential contracts. General Dynamics proposes the XM806. It's revolutionary, titanium components, polymer parts, computerized fire control, and a weight reduction of 40 pounds compared to the M2's 84-pound base weight. On paper, it's everything the M2 isn't: modern, lightweight, sophisticated. Testing begins in 1987 with high expectations. The XM806 will finally retire Deuce. Except it doesn't work. The lighter components can't handle sustained fire stress. After 500 rounds, receivers crack. Bolts shear. The polymer parts warp from heat. The computerized fire control fails when exposed to dust, moisture, and the shock of repeated firing. By 1990, the XM806 program is quietly canceled after spending millions. The M2, despite being obsolete, continues service without modification. The Pentagon tries again in 2003 with the XM312. This time, designers focus on modularity, a weapon system that can fire .50 BMG or convert to 25mm airburst ammunition. Advanced recoil mitigation, reduced weight, improved accuracy. The specifications promise a quantum leap over Browning's ancient design. Testing reveals familiar problems. The recoil mitigation system is too complex. The modularity adds failure points. When exposed to dust and sand during desert trials, the XM312 jams repeatedly. The M2, tested alongside it, functions flawlessly in identical conditions. Program managers face an uncomfortable truth. They can't beat a design from 1918. Every attempt to improve on Browning's work adds complexity that creates vulnerabilities. The M2's simplicity, what critics called primitive, is actually its greatest strength. Fewer parts mean fewer failure points. The massive steel construction can't crack like titanium or warp like polymer. The mechanical fire control never needs batteries or software updates. BY 2005. The XM312 program is cancelled. Total cost: approximately $20 million. The M2 continues service, now over 70 years in the fleet, still firing with the same reliability it demonstrated in 1933. Some of the M2s in service during the XM312 trials were manufactured before the engineers trying to replace them were born. The fundamental problem these programs encountered was philosophical. Modern weapons designers approach problems with the assumption that complexity equals capability. More features, more adjustability, more technology. Browning designed from the opposite direction. Maximum capability through minimum complexity. His operating system uses the recoil energy that already exists. No gas system to foul, no regulators to adjust. His air cooling system uses ambient air that's always available. No coolant to leak or freeze. His mechanical components are steel forgings that can be repaired by any competent armorer. No proprietary electronics or composite materials requiring specialized tools. The military establishment learned what soldiers already knew. Deuce doesn't need replacing because she's not actually obsolete. Age doesn't equal obsolescence when the design remains functionally superior to modern alternatives. Iraq 2003. Operation Iraqi Freedom. The M2 Browning, now 70 years into its service life, mounts on every Humvee, every Bradley fighting vehicle, every Abrams tank. Some of these weapons were manufactured in the 1940s and 1950s, fighting their third or fourth war. Armorers performing pre-deployment inspections discover M2s with serial numbers dating to World War II still functioning perfectly after 6 decades of service. Urban warfare in Fallujah and Ramadi reveals new M2 capabilities. Marine snipers mount high-powered scopes on carefully selected M2s, creating improvised anti-material rifles capable of engaging targets at extreme range. Staff Sergeant Steve Reichert of 3rd Battalion, 8th Marines achieves confirmed kills at ranges exceeding 1,800 yards using a scoped M2. The weapon's inherent accuracy, often overlooked because it's a machine gun, proves exceptional when fired in single-shot mode from a stable position. The .50 BMG round's penetration capability becomes essential in urban combat. Insurgents hiding behind walls, engine blocks, or concrete barriers aren't safe from M2 fire. The round punches through masonry, vehicle bodies, and barricades that stop rifle fire completely. During the Second Battle of Fallujah in November 2004, M2s provide crucial fire support, engaging fortified positions that infantry weapons cannot penetrate. IED warfare, the defining threat of Iraq and Afghanistan, makes the M2 more valuable than ever. Vehicle-mounted M2s provide gunners with standoff capability to engage suspected IED emplacers or ambush positions before convoys enter kill zones. The weapon's 2,000-yard effective range means American forces can dominate engagement distances where insurgents with AK-47s and RPGs cannot effectively return fire. Afghanistan's mountain warfare presents challenges where the M2's long-range capability proves decisive. Taliban fighters engage American positions from ridgelines 1,500 to 2,000 yards distant, ranges where M4 rifles and even M240 machine guns struggle for effective fire. The M2 reaches out and touches them. Forward operating bases across Afghanistan typically have multiple M2s in defensive positions. They're heavy bullets capable of defeating cover that lighter weapons cannot penetrate. Temperature extremes that break modern weapons don't affect Deuce. In Iraq's summer, where temperatures inside vehicles exceed 140 degrees Fahrenheit, M2s function normally. In Afghanistan's mountains, where winter temperatures drop below zero, The weapons fire without lubrication freezing issues that plague other systems. The mechanical simplicity means there's nothing to freeze except metal expanding and contracting, and Browning's tolerances accommodate that. Maintenance becomes a point of pride among armorers. Some units field M2s that have documented firing histories exceeding 1 million rounds. The barrels have been changed multiple times. Barrels are expendable components expected to wear out. But receivers, bolts, and other major components show remarkable durability. Armorers discover that properly maintained M2s essentially don't wear out. They might need parts replacement after extreme use, but the weapons themselves remain serviceable indefinitely. The Marine Corps conducts a study in 2008 examining M2 reliability across combat deployments. The findings are remarkable. Properly maintained M2s have a malfunction rate of less than 0.02%, 2 failures per 10,000 rounds fired. Modern weapons with computerized fire control systems and advanced materials struggle to achieve half that reliability. The 75-year-old design outperforms everything designed to replace it. Understanding why the M2 outlasts modern weapons requires examining what Browning got fundamentally right in 1918. The engineering principles that make this gun immortal weren't accidents. They were deliberate choices based on deep understanding of mechanical systems operating under extreme stress. Every component reflects design philosophy that prioritizes reliability over sophistication, durability over weight savings, and field maintainability over manufacturing convenience. The recoil operation system is mechanically elegant. When fired, the barrel and bolt remain locked together, recoiling rearward approximately 3/4 of an inch. During this short recoil stroke, a cam path unlocks the bolt from the barrel. The barrel stops, held by the barrel extension, while the bolt continues rearward, extracting and ejecting the spent case. A return spring drives the bolt forward, stripping a fresh round from the belt, chambering it, and locking into the barrel as both return to battery. The entire cycle happens mechanically, no gas system to adjust, no regulator to tune, no settings to configure. This simplicity means fewer failure modes. Gas-operated weapons rely on precisely calibrated gas ports that can foul with carbon or become damaged. The M2 has no gas system. The recoil energy that must be managed anyway provides all the operating force needed. Browning turned a problem, recoil, into the solution. The barrel design reflects profound understanding of thermal management. The M2's barrel weighs approximately 24 pounds, massively overbuilt by modern standards where engineers obsess over ounce saving. But that mass is thermal capacity. During sustained fire, the barrel absorbs tremendous heat without reaching temperatures that affect metallurgy or accuracy. Modern lightweight barrels overheat quickly, requiring frequent barrel changes or reduced rates of fire. The M2's barrel can fire 200-round bursts repeatedly before heat becomes problematic. The heavy barrel also provides rigidity that enhances accuracy. Thin barrels flex during firing, causing point-of-impact shifts as they heat up. The M2's barrel remains dimensionally stable through temperature extremes, maintaining zero even after firing hundreds of rounds. This is why Marine snipers can use M2s for precision fire. The weapon is inherently accurate when fired from a stable platform. Belt feeding system uses a simple mechanical linkage that's virtually indestructible. As the bolt recoils, it drives a feed slide that pulls the belt laterally, positioning the next round for stripping and chambering. The system works with dirty ammunition, corroded belts, and even damaged rounds that would jam more sophisticated feeders. The tolerance for poor ammunition quality proved essential in World War II when ammunition from multiple manufacturers with varying quality control had to function reliably. Headspace and timing, the critical adjustments that ensure the gun fires at the correct moment in the operating cycle, are manually set using simple gauges. Modern weapons often use complex auto-compensating systems that fail unpredictably. The M2 requires an armorer to check and adjust headspace and timing manually, a process taking about 5 minutes with proper tools. This manual adjustment means failures are immediately identifiable and correctable in the field. The quick change barrel system allows replacement in under 2 minutes by a trained crew. Remove the barrel latch, pull the barrel extension and barrel assembly forward and out. Insert the replacement barrel, close the latch, verify headspace and timing. No special tools beyond the headspace gauges required. 2012, the U.S. Army finally acknowledges that Deuce isn't going anywhere. Instead of replacing the M2, they upgrade it to M2A1 configuration, the first significant modification in 79 years. The changes are telling in what they don't alter. The fundamental operating system remains identical to Browning's 1918 design. The barrel, bolt, receiver, and recoil system are unchanged. What engineers modify are the external features that cause maintenance headaches without affecting core functionality. The M2A1 introduces a fixed headspace and timing system that eliminates the need for manual adjustment when changing barrels. The quick change barrel system now allows barrel swaps without gauging, reducing change time from 2 minutes to under 30 seconds. A flash suppressor reduces muzzle signature. A soft recoil buffer system reduces felt recoil and improves accuracy. These are refinements, not replacements. The Army isn't fixing the M2. It's making the perfect gun slightly more convenient to maintain. The decision represents pragmatic acceptance of reality. After spending millions trying to develop replacements that failed, the military admits that Browning's century-old design remains the best .50 caliber machine gun ever created. Modern materials, computer-aided design, and advanced manufacturing cannot improve on the fundamental architecture. The M2A1 upgrade essentially says, "We can't build anything better, so we'll make this one easier to use." Special Operations Forces provide perhaps the most telling endorsement. These units have unlimited budgets and access to any weapon system they want. They can requisition experimental weapons, foreign guns, or custom builds. They choose the M2. Navy SEALs mount M2S on riverine craft and vehicles. Army Special Forces use them for base defense and vehicle-mounted fire support. Delta Force and DevGru include M2S in their arsenal despite having access to every modern alternative. Why? Because when you're operating in remote locations with limited support, you need weapons that absolutely will not fail. The M2's track record of reliability over 100 years of service in every environment, every climate, and every tactical situation provides confidence that no modern weapon can match. Special operators trust their lives to guns that were designed before their great-grandfathers were born. The global proliferation of the M2 tells its own story. Over 100 nations currently field M2 Brownings. Many are operating guns manufactured in the 1940s and 1950s that were sold as military aid, captured as war trophies, or acquired through various channels. These weapons continue functioning despite minimal maintenance, harsh environments, and decades of hard use. In some developing nations, armorers maintain M2S that are older than their country's independence. Insurgent groups, terrorist organizations, and non-state actors who capture M2S prize them above modern weapons. Videos from Syria, Libya, and Yemen show technicals, pickup trucks with mounted weapons, carrying M2S as their primary armament. These fighters could choose from vast quantities of captured modern weapons, but they select the American gun from 1933. They know from experience that Deuce will fire when needed, won't jam at critical moments, and can be maintained with basic tools. The ammunition .50 BMG has proven equally enduring. The cartridge Browning designed in 1918 remains in production worldwide, with billions of rounds manufactured annually. 2025, the M2 Browning is 107 years old. It has served continuously longer than any firearm in military history. Guns designed to replace it in the 1980s, 1990s, and 2000s are museum pieces or canceled programs. Deuce is still mounted on Humvees, Strykers, Bradley fighting vehicles, Abrams tanks, Navy vessels, and aircraft. She's fighting in Ukraine, where both sides prize captured M2S. She's defending U.S. bases in the Middle East. She's training the next generation of American soldiers who will inherit a weapon their great-great-grandfathers carried into battle. The lesson the M2 teaches isn't about nostalgia or resistance to progress. It's about fundamental engineering philosophy. John Moses Browning designed the M2 to do one thing supremely well: fire .50 caliber ammunition reliably under any conditions a soldier might encounter. He didn't add features that would be nice to have. He didn't optimize for manufacturing cost or weight savings that might compromise function. He built a machine that would work, period, using the simplest mechanical means possible to achieve that goal. Modern weapons development has forgotten this approach. Contemporary designers add complexity in pursuit of marginal improvements. Computerized fire control, advanced materials, modular systems, all sound impressive in procurement presentations. But complexity creates fragility. Every additional component is another potential failure point. Every electronic system needs power, software, and maintenance expertise that might not exist in combat conditions. The M2's immortality comes from having nothing that can fail except the fundamentals, and those fundamentals are overbuilt to the point where failure is nearly impossible. The receiver is a massive steel forging that would require deliberate destruction to break. The bolt is similarly overbuilt. The recoil springs can be replaced with hardware store springs in an emergency. The operating system has no adjustments, no settings, no calibrations beyond headspace and timing. It works or it doesn't, and it works. Soldiers' testimonies across 11 decades repeat the same themes. The gun is heavy, 84 pounds unloaded, but weight equals reliability. The gun is simple, critics called it primitive, but simplicity equals durability. The gun is old, over a century since conception, but age doesn't equal obsolescence when the design remains functionally superior to everything newer. When the Pentagon eventually retires the M2, it won't be because better technology replaced it. It will be because warfare itself has changed so fundamentally that heavy machine guns become obsolete, or because directed energy weapons finally mature enough to provide equivalent capability through completely different physics. But that day isn't coming soon. Current projections suggest the M2 will remain in U.S. service beyond 2050 to 132 years after Browning designed it. Some M2s in current military inventory were manufactured in 1933. They've fought in World War II, Korea, Vietnam, Desert Storm, Iraq, Afghanistan, and smaller conflicts most people never heard of. They've fired millions of rounds. They're still serviceable, still accurate, still reliable. Armorers who maintain them speak of the weapons with respect bordering on reverence. These aren't just guns. They're mechanical proof that perfect engineering transcends time. John Moses Browning died in 1926, never seeing his final masterpiece enter service. He couldn't have known that in 2025, nearly a century after his death, soldiers would still trust their lives to his design. But perhaps he did know. Perhaps he understood that when you build something right, truly right, it doesn't become obsolete. It becomes immortal. Emma Deuce is immortal. And she's not retiring anytime soon.